All right, when you're looking to solve this absolute value equations, okay, what you need to do is you need to isolate the absolute value expression. In this first example, that's already done. In the second example, it's not done, so you do need to do an extra step in that one. Once you isolate the absolute value expression, you will then split your equation. Each equation that you split will begin with the identical expression that's inside the absolute values. On one side, you're going to set it equal to what's given. On the other side, set it equal to its opposite. So change the sign. And then you're going to solve each of these equations independently. So if we solve the left side, isolate your variable term. So we subtract a 5 from both sides. Divide by 3. So you get x is equal to negative 28/3. And on the right side, do the same thing. Perform your steps. Isolate the absolute value expression by subtracting 5 from both sides. Divide both sides by 3. You get x is equal to 6. And so those would be your two solutions. And you can test them, plug them in to make sure they work. You can also use your calculator to verify this. So if we verified using our calculators, we could use the solve capability, type in our expression in absolute value. Remember, in absolute value, you either need to type the letters ABS parentheses, or you can find that under the math key. The math key is located in second function 5. Underneath number, you'll see ABS as the second choice. All right, so you can either type it in or find it on your calculator. Type in the expression that's inside the absolute values. Close it off. Set it equal to 23. Identify the value of x that you want to solve for. Hit enter, and it confirms negative 28/3 and 6 as our correct answers. Okay, same thing for problem 35. Here you need to isolate your expression that's in absolute value, so we need to add 8 first. So we get 2x minus 4 in absolute values is equal to 18. And then you do the exact same steps that we did up here. Split it. In both parts of the split, you're going to begin with the expression that's inside the absolute value. On the right side, set it equal to the given 18. On the left side, set it equal to the opposite of what's given. And then go through and solve each one independently. So add 4 to both sides to isolate your variable term. Divide by 2, and you get one solution of 11. And so now when we confirm with the calculator, we see negative 7 or 11 would be the correct answer for that. All right, questions on solving the absolute value equations? Okay, solving the absolute value inequalities. So in this case, once again, the steps are the same. You isolate the expression in absolute values. And then you're going to sandwich or split depending on what the inequality is. So if the inequality is greater than, what are we going to do with this inequality? Remember, they're either sandwiched or they're split like the oars of a boat. So the oar is split. So we're going to split this. When you split it, once again, both sides will begin with exactly the expression inside the absolute value. On the right side, you're going to have identical to what was the whole expression was, greater than 4. On the left side, you're going to compare it to a negative, the opposite of this. And when you're dealing with inequalities, anytime you multiply or divide by a negative to change the sign, what do you have to do with the symbol? Flip it. So now we flip this symbol, and you're going to solve each individually. So now as we go through to solve this, subtract a 3 from both sides, get 2x is less than negative 7. Divide by 2. So we get x is less than negative 7/2. On the right side, subtract a 3 from both sides, leaving you with 2x is greater than 1. Divide by 2. You get x is greater than 1/2. Now, we're expecting our graph to look like this, to be split. Because there's no equal to, it should be parentheses here. And so you just need to find the lower and upper limit. Our lower limit is negative 7/2. Upper limit, or I'm sorry, the limit, the two critical points are negative 7/2 and 1/2. 1/2 is further to the right. So you can label this. This is kind of what your graph will look like. So when you identify your interval notation for this, what you need to be able to do is write your solution in interval notation. The left interval goes from negative infinity all the way to negative 7/2. Negative 7/2 is not included in the set, so it's a parentheses. The right interval starts at 1/2. That's the lowest limit of that interval. It extends all the way to positive infinity. And because you have multiple intervals in your set, you need to use the union of set symbol, the U, to join them. So here is what your interval notation would look like for that problem. Okay, let's confirm it with the calculator. Okay, your calculator can be used to solve absolute value inequalities as well. Once again, it's all set up to solve it. You solve absolute value, write your expression that's contained in the absolute value. Here it's greater than, so we can use the greater than symbol for, comma, isolate, or tell it what to solve for the x. And so we get x is less than negative 7/2, or x is greater than 1/2. It confirms this step right here. And it's just a matter of translating that into the interval notation to get the correct answer when you guys take your quiz or test. Okay, the last example here. Again, same thing. You need to isolate this absolute value expression. So this one requires an extra step to do that. Okay, so we take 3 plus x in absolute values. We're going to subtract 7 from both sides. Do I need to change this inequality symbol since I subtracted a number? No, again, it's only when you multiply or divide by a negative, not when you add or subtract. Okay, and so you can compare that. Now, as you work to move here, here you have a less than. A less than is an and inequality, so a less than is going to be sandwiched. So when you look at this expression, 3 plus x, you're going to sandwich it between what's given and the opposite of what's given, and then you're going to solve this compound inequality. And so when we solve this inequality, subtract the 3 from both sides, or all parts, to isolate the x in the middle. 3 minus 3 is a 0. Negative 3 minus 3 is negative 6. So here is your interval, or your inequality notation. If you look at the graph of this, the graph for this has a critical point at negative 6 and one at 0. There's no equality to your inequality symbol, so it's a parentheses that is sandwiched between those two critical points. And so when you write your final solution in interval notation, you'll write your lower limit, your upper limit. Neither of those are included, so you'll have parentheses to join them. Once again, we can use our solve feature for this. Take the absolute value of 3 plus x, close it off, add 7, set that, less than 10, comma x to identify what you want it to solve for, and you should see that it verifies your solution. Negative 6 is less than x, which is, or I'm sorry, negative 6 less than x, which is less than 0, and then you need to translate that into the interval notation. Okay. Any